Alright, so this is the first progress update on my computer. I do have to apologize for the world being surrounded in an eternal void. I do not know why that's happening. It is on a server, so that's probably the explanation, because 1.14 does not like servers. Anyways, onto the computer. In its current state, it has its main program memory, which is 64 words long. It has the jump control, so this will control the instruction pointer. And it has the state machine, which controls what the clock does, or like where it goes, either here or over here. And it has this, which is the microprogramming ROM, which determines what the instruction will actually do. And how this works is we have the control signals all arrayed like this. And so anything on the top will either turn something on if it has something below it, or it will give it a pulse, such as to the right register clock. And then anything on the bottom will turn something off, and this is a special case for conditional jumps. And then over here, this is the next instruction stage, which controls the bottom of this address. And this system is where the top is the current opcode, and the bottom is the current part of the opcode. This is explained better by the specification document, which both of those are linked in the description, one for the ISA and one for this implementation. And then there's also in the description a block diagram version of this entire thing with some digital logic implementations. So for the jump control, we have the current address, which goes over there, and then there's an incrementer here, which is a series of adders, and it goes to here, and it's multiplexed between that and either the current data, the top of the stack, or itself. And this is the return stack, which holds the address to jump to when returning from a subroutine. And so then here is the ROM, and the current, something is broken over there, I'm not sure what. I'll be fixing that, of course. So this is the state machine, and it takes this clock, this can be anything, this is the input for it, and it will output to here until this is pulled high, and then it will output to here once, and then continue outputting to here. And when it outputs to here, it will update the current opcode and the current data to whatever is being addressed. And so that is an overview of the full computer. Apart from basic designs, this is like my own basic, I mean like the ROM structure or whatever, and that I did not design. I found it. I don't remember who it's by, but it's very compact and very nice. And for the rest of the computer's architecture, it's a stack-based design where the ISA is designed such that the opcode is the only part that is fixed length, and then the second half or second part of the instruction is whatever data is needed. And so that's variable length, and in this implementation is 6 bits, and so that's why there's the 6-bit address for ROM. It's a stack-based design where it's based off of a different ISA I designed and never implemented, which was based off of the Java virtual machine, or inspired by it. And so it has, it's all stack-based. There's a design document in the description, along with a circuit diagram of the final product, with some of these parts, importantly this right here, implemented in digital logic. And so that's the first update for the Redstone computer.